Hello everyone, welcome back to the session on your file system interfaces. So in this particular session, we are going to discuss about the remaining part of your file system interfaces. In the previous diagram, in the previous session, we discussed about the basic concepts of your file system interfaces that we have discussed. So what are the basic concepts we have here is nothing but what do you exactly mean by file? What do you mean by directory? That we have gone through it. And after that, we discussed about something relevant to what we call is nothing but the types. What are the different type of files we do have, and what are the attributes that are associated with that particular file that we have discussed it. And later on, after discussing about the attributes and types, we have seen the extensions related to that particular file. So what are the different extensions we do have, like .exe for executable, .doc for text files, .c or .java for your source files, and .obj or .o for your object files. So these are the one what we have discussed in the previous session. That is the basic concept related to file. And we also discussed that without files, our means if we want to store any information in our system, so okay, if we want to store any information in our system, so definitely files are basically required. If we do have files, then only we can store the information in our system. And where these files are stored, that also we discussed, that is nothing but your secondary storage device. That is your secondary storage device. That is nothing, you can call it as your hard disk. Okay, you can call it as a hard disk here. So we have seen that in the previous session we had discussed about the hard disk here, something we discussed about something called magnetic tapes. Then we discussed about something called as disk. So all these are relevant. Whatever the information we are going to inbuilt or incur in this particular file system that is related to your disk. That is what we are actually going to discuss in this particular scenario. Okay. Okay. So let's begin. Let's move to the next topic. Next slide. Okay, so basically first we have discussed about file concept. There we have discussed about whatever I have explained in earlier. And then today, in today's session, we will try to cover basically few means something like, okay, sorry. So in the today's session, we'll try to cover basically the access methods. So what are the access methods we do have in order to access the files? So that we will discuss. And coming to the disk and directory structures, we have actually around three to four different type of directory structures. But basically, we will try to cover some two types of directory structures in today's session. So first, if you talk about the access methods here, these are basically classified into some two types here. Basically, we have mostly we know about, that is nothing but your sequential and direct access method. So we have two different access methods here, sequential access method and direct access method, that will come across in this particular concept. Okay, and after that we'll discuss about the directory structures here. Four to five different type of directory structures. Among them we'll discuss the two. Those are also very easy one. We have a single level directory. Okay, and then we'll discuss about something called as two level directory. So we are going to see the different type of directories where we can store a related kind of files, okay, within the system. So that we are going to see it in this particular session. So without wasting time, let's go to the file structures. So we know that first we will discuss about the basic information related to your file structures. Okay, so file structures, what is saying is, how can we determine the structure of the file? Basically, we are saying that files, we have many different type of files. We said that we have some different type of files, right? We discussed in the previous session. What are the different type of files we have? We have executable files, right? We have executable files. Then we have source files. Then we do have something called as text files. So this is what we have seen, the common one. So if you talk about the executable files, all the files that end with .exe or .com, those are what we call it as executable files, mostly applications. So mostly all the applications comes under in this particular view. And coming to the source file, we discussed that we like .doc for your Word. Word means Word document. Microsoft Word if you are using it. .txt for your text, and if you, that is with respect to your Windows, that is the extension. But if you talk about something called your Mac operating system, .tex, this is for your Mac operating system. Same way if you talk about Linux, it will have a different text files. Okay, so that sorry, this is related to your something called text files. Okay, this is related text files. Now, if you talk about the source files here, source files are nothing but your programming, all the programming content, all the different type of programming, whatever you people are writing, those all programming related information like .c, .java, .php, all this comes under that. Now, what it's saying is that in this particular, in order to determine the file structure by the system, what it's saying is based upon this particular extensions, the system will come to know what kind of structure this particular file is having. Okay, so some system operating system expect that based upon the extension whatever we are providing, like if you are representing something we have here like .exe. So if you're representing anything like .exe, the system will come to know that it will have a certain specific kind of structure. Remember that whatever the structure for .exe we will be having, that will be entirely different from the structure what we have for .c. Both are entirely different. Okay, because programming source files are entirely different from executable file, and the operating system expects that whatever the files we are storing, they should have a different structure based upon the extensions whatever we are using. Like we are using .exe means it should have a different structure. It should have a different structure. So if you're using .doc, okay, so this one should have a different structure. That is what he means to say. Everything should have a different structure. It's not that or .doc should have a same structure as that of .exe. Both are entirely different. These are executable files. These are for writing the content. Okay, that may be alphanumerical that we have discussed in the previous session, right? It can be alphanumerical, numerical, okay, or it can be something called alphabetical. So that we have discussed, sentence formation, word formation, whatever, that data we are storing here. Okay, but whereas coming to .exe file, that is the executable file where we will be, installing some apps within that. So here what is saying, the file structures can be determined by the system. This particular file structures can be determined by the operating system based upon the type of extensions we are having. And apart from that, we also have something depending upon the fixed length of variable length. Based on that also, we can also determine what kind of file it is. Okay, but basically that should be decided by the operating system. See, we cannot decide whether it is text file or executable file. If I give you some file which is having some different kind of symbols, if I ask you what kind of file, you people will not be able to answer it. If I give you the Word document or something like that, you can determine it. But whatever the other, we cannot determine. So it's actually the operating system is the one who actually decides what kind of file it is. And same with the programs. Whatever the programs we are writing, it's the responsibility of those programs to determine how to determine that which particular file belongs to which particular structure. Okay, so that is what. For example, if you take about your editors, so where you people write all the programs. Okay, same way you people have something like compilers. They have different kind compilers. The compiler generally compiles this program. This compiler is also a software written by some programmer. It is a software which is written by some programmer. Now this particular software will have some structure, and that structure is with respect to your editor. Okay, so this editor, even editor, if whatever the editor you might be using, that blue color screen, you use it for writing the program in C language, like Turbo C and all. That is also a software which is written by some programmer. Okay, so definitely that will have some kind of structure. Okay, so those are .exe files. Okay, this editor, compiler, these are .exe. These are .exe files. So they should have a different kind of structure when compared to you people are writing in a document .doc file. You are writing a program that is entirely different from what you people are writing in a compiler. Editors. Okay, so that is what he means to say. So using this every dot based upon the type of the file what we are seeing, based upon the extension, we can find it out which particular file belongs to which particular structure. Now let's come to the file access methods. Basically, as I told you that we do have, we do have some two different types. Okay, so actually we have so many, but the most common what we discuss is two types what we have. So first one is sequential access, and another one is something we have here is this direct access. So if you talk about the sequential access, let me show you. Okay, if you talk about the sequential access, we are going to sequential access. If we are talking about here this particular session, sequential access is nothing but we can allow the system to access the information present in the file sequentially. Means whatever the data you people are storing into the files, we can access the information from files. Access information from files sequentially. We can directly access it. Okay. So here sequential, moreover, what he's saying is this is the easiest one what we have with respect to direct access method. Here, whatever the information you people are storing, that will be in a sequential manner. And the best example for this particular sequential access is something like editors, what we use it for C programming, and then we have compilers. Now these two comes on sequential access because all the data will be represented in a sequential manner, and so we need to access the data from this particular right from the compiler editors. So that will be in a sequential manner. That is what it's saying. Now, if you talk about the operations, what kind of operations we apply on the sequential access? Well, we have two different type of operation, one for read, one for write. Okay, so that is nothing but read next. Now, what this read next exactly does it? As I told you in the previous session that we have a file, you people have read some content, and then you have closed that file. After some time, you have opened it and you want to read it from where you have stopped. Then we are maintaining a pointer which will indicate from where we need to start, right? So that is what the task of this particular read next. It will try to read the next portion of the file, okay, and automatically it will advance that particular read pointer. So read next will have a pointer called read pointer. Next, what it will do, this method will try to read the data. After reading the data, it will move this particular read pointer to the next location. Means first, whichever the part we have completed reading, it will move to the next one, so that whenever we start reading the next time, it will start, it doesn't start from the beginning. It can start from where we have stopped it. So we have, same way we have something called write pointer here, write next. So what this particular write next does here is nothing but whenever we want to write a data to a particular file, it will continue it. Okay, so this write next, what it does is, it will simply append the text. Whatever the text we want to update in that particular file, it will simply update it. For example, if I have a file here, I'm writing hi, I closed it. After some time, I have opened it and I just want to write after hi, I want to write how are you? How are you? So what the pointer, so what this read next, write next will do is, whenever this file is opened, it will start writing from this particular location. It will not start from, because here write next also consists of a write pointer. That write pointer is also updated. This we have already discussed about read pointer and write pointer in the previous session. So these are the two what we have and using which we can perform operations. Okay, so read next is used for reading the portion of the file and automatically it will update the read pointer to the next location. Whereas coming to the write next, what it is going to do, it will append. It will simply append the new content or the new information to the existing file, and it will update that particular write pointer to the next location from where we should start writing the next time whenever we want to add a new content. Well, apart from that, when we were discussing about the different type of operations what we can perform, we discussed one topic, one operation called repositioning. I don't know how many of you remember this repositioning. So this repositioning, what it can do, it can actually try to reposition this pointers, this read pointer and this write pointer. It can reposition it. How it can reposition it? It's very simple. We have to simply locate it. Means these are nothing but the way this methods will have some variable. So that variable will be making it as some C variable or something like that will be having. So we'll make it as 0. So it will come to the beginning from the beginning. So that is what we have a method. So we have a method here called as reset. So it will reset the particular read and write pointers to the beginning, and from there we can start performing the operations whatever we wanted to do. So that is related to your sequential access. But whereas coming to the direct access, okay, so this direct access is actually consists of files. This actually consists of already been represented. It has files of fixed length logical records. Okay, so here files will not be in a sequential. Here, whatever the files that we are storing into our system using this direct access, that will not be stored in a sequential manner. Rather, that will be stored in a fixed length. And if you remember, we people are dividing the file into pages. Whatever the information, like in the third unit, we discussed about pages. Then we discussed about frames. What we are doing? Whatever the process is coming, we are dividing that into fixed size pages, and that pages we are storing in a fixed size frame. The same process is actually going to take place here. Whatever the file we file we will be chopping it up into fixed length, and that is what we call it as logical records. Well, you people have to take care here. I'm talking here related to logical records. I think you people should understand why we are calling this as logical records. If you remember the second unit, we discussed about something like no, CPU generates logical address. If you remember this, okay, page number and displacement. This page number we are storing it in your page table, and from there you get some value. That is a frame number, right? This frame number, and that frame number we are adding to this particular displacement, and then finally we are getting the actual physical address, right? This is your RAM. This is your physical memory RAM. From there you're getting same way. Why? That's the reason we are calling this as logical address. You can see here this one. Why I'm calling it logical address is CPU generally generates logical address. So whatever the file we are seeing, this is a logical record. Now this record will be stored in our physical memory, that is your RAM, using the concept that we have discussed in the second unit. This one. If anyone have any doubts related to this particular concept, you people just visit my previous video and just go through it. Okay, so here one thing we have to do, since we are representing the files in a format of blocks. Okay, let us suppose this is your file and I'm representing in a format of blocks like this. So what happens here, definitely like here we use something called read next and write next in your sequential access, but here we need to provide the block number. If I want to block number, if we want to access any information from a particular file, I need to provide a block number from where. So these block numbers are present like this, 1, 2, 3, 4, 5, 6 in this way. So I need to determine which particular block information I want to access, that number has to be provided. For that, what we are using here is that we need to pass a parameter called n. So read n, write n. So write is a method, read is a method, and methods are represented in brackets. So read n means it is asking you to read the data present in a block, whatever the number we are giving. For example, read 5. So it is asking you to read from the block number 5, whatever the data is present in that. Same way, write 5. That means write the information. Write whatever the new content you are having information into the block whose number is 5. That is what represented here. Okay, well, if you don't want to use in that way, okay, for example, you don't want to use in that particular way, you just wanted to use the sequential, means whatever the methods I have provided in sequential access, read next and write next, you want to access. Same methods you want to use here into your direct access method, yes, you can do it. But before that, you need to use this particular information, position to n, because as I told you that we are actually dividing our files into fixed size blocks, and within them we are storing the information. This is your file. This one is your file, and with this file we have allocated some spaces to it. And what we are doing, whatever the information is present in that file, we are chopping and placing into this particular boxes. So we need to get information. So we need to, in order to read the information, we need to get that particular block number. Initially maybe starting from 0, 1, 2, 3 like that. Okay. So that information, that n value need to be provided. That's the reason we are using position to n. Once we are calling it, then you people can directly call read next, write next. Based on that, read next will perform the same operation what it was doing in your something called as here, and same way write next will perform the same operation what it was doing in a sequential access method. Okay, so n is nothing but the relative block number. Okay, basically, okay, let me draw the diagram and show you how it exactly looks. Well, basically, internally your backing store, if you remember the backing store, how it looks, this is the backing store, and within that we'll be having blocks like this. This is what we call it as random access blocks. In the backing store, the information is stored in a format of random access blocks. Means randomly the data will be stored. Like from one particular file, I have a file xyz.c. This will be converted into .obj. Okay, fine, we know that. Well, I want to store this xyz into C. Means whatever the program you have written here, like something like you might have written main int a comma b comma c, c equal to a plus b, let us suppose something. I am not writing the entire. So this particular program consists of, this is what sequential is stored. If you use sequential access, sequentially the information is provided. But when you use direct access, this information will be chopped. Like this main, this variable, I mean this main will be stored in one block. This curly bracket open, bracket close. This might be used in some different block. Same way, this bracket might be stored in some different block. This one in a different location. Something like, for example, come back to here. So here I am storing this variable main. Now in this particular block, I might be storing this open brace. In this, I might be storing close brace. Means the operating system stores in this way. Okay, whereas coming to curly braces, it will be stored here. It is not storing sequentially. 0, 1, 2, 3, 4, 5, 6, 7. You can see it. But whenever you try to access the data, the system will provide you in a sequential manner. Whenever you open a file, you will get in this order only. Main, bracket open, int a comma b. In this way only you can see. But internally when it is storing it, it will not store in this particular way. So that is what is saying in this particular scenario. I hope till here it's understood. If people are following it up. So basically we have only two different methods here. One is your sequential access, another one is your direct access. And using them only we are performing the operation. There is no much different. Only thing is in direct access, the information is stored in a format of fixed size blocks. But whereas coming to sequential information, the info is stored in a sequential manner. So definitely in sequential manner means we don't require much methods. So directly we can use regex, mytext, and we can. But here since we are storing into this block, every block will have some number. So we need to first access that particular number. Okay, that block number has to be accessed, and then we can start performing operation on that particular block. Means either we can read the data in that, or we can write the data in that particular thing. So this is the one we are having in this particular step. Now, as I told you related to repositioning, right? If you remember repositioning, so for that, this is the diagram given here. So if you see here, initially, this is the current location of your pointer. Okay, and from here you are performing read write. In case I want to read it from the beginning, I can use the rewind, and from here, then this current position will come back here. It will start from here and it will start processing it. No, I want to go a little further, then I can just move to the little further, and from here I can start accessing this content. This one I don't want to read it up. So that also we can do it. That is what comes under repositioning. So this is all what related to your file access method. Now here as I told you that the sequential access method can be implemented with respect to your direct access method. So here is given a small example related to it. How we can implement a sequential access method in your direct access method. So if you see here within this particular table, we have first reset, and that reset I am going to apply using direct access method using CP equal to 0. So this is a variable. CP is a variable. Okay. So reset is nothing but this is a method. This method will have some variable internally that will be performing the operation. But here if we come across this CP, if I am applying this sequential access in a format of a direct access, this is a code. So if you use sequential access directly, you can call reset. It will reset that particular pointers, read and write pointers, it will automatically reset it. But if you talk about a variable here, implementation with direct access, you need to give a variable called CP equal to 0. Any variable you can give it. So CP equal to 0 means it will come to the current location, starting point. Next method what we have is read next. Read next, what it will do, it will try to read from where we have stopped previously, right? And it will update the read pointer. But whereas coming to that, if we want to execute the same thing here, we need to use read CP. Okay, first we need to read from where we need to start. So we will read it up. Once the read is completed, we need to update a pointer, read pointer. That is what we are doing in the second step. CP equal to CP plus 1 means CP will consist of the entire location which we have to read. After that, we are incrementing that with plus 1 means we are going to this location. So whenever we want to access, we will be accessing from this particular location. Let me show you with the diagram so that it becomes clear. Here. Suppose this is the data we have here. Some content is represented here. Okay, so if you CP means if you're starting from the beginning, so this is the data you have read in the first portion. Next time what we have to do, next time when we open it, we should read it from this particular location. That's what we are doing, CP equal to CP plus 1. So initially CP is this. When you call CP plus 1, it will come to this particular location. So next time whenever we try to read that particular application or anything, it will start reading from this particular location and this information it will read. Same way coming to the write. I want to write some content. As I told you, hi. So initially write up. So write CP for direct access method. So sequentially we can simply call write next. It will execute it. But whereas coming to direct access, if you are implementing, first we need to call write CP. So here it will write the content hi. So next time whenever I'm writing, where we need to start? We need to start from this particular location, right? So for that I'm calling CP equal to CP plus 1. I'm simply incrementing it. So next time whenever I write how are you, so it will start from this particular location, not from this particular location. This is the way how it exactly works. Okay, this is nothing but the simulation of your sequential access method into your direct access method. And the next what we have here is nothing but other access methods. So those are the two what we have. Apart from that, we have other access methods too. So in this what we do. So basically in other access methods, what we are going to do is we are going to use the index concept. I think you people know about index. In our textbooks, we have index. So whenever we want to get a specific topic, we will search a particular index. From there, we will get the page number, right? Page number. And using that page number, we'll directly go there and we try to access the information. Same way in the other access methods, what they are going to do, they are going to use the concept of index. Using this index, they will try to determine the location. Okay, they will try to determine the information related to that particular block, and that information will be read or it will be write up, will be performed based upon whatever we are having. Okay, so these are the other methods what we have, and basically this method is mostly used. Okay, and here well with this example, I mean this access method we have already seen in the previous chapter. That is nothing but your third unit, where you people are maintaining a page table, right? Page table. The CPU generates a logical address P comma D. This P will act as an index. That is what he means to say index here. So this P will act as index. From that particular page, we will get a frame number. That frame plus displacement we are adding from here, and then we are finally getting the physical memory, right? So that index is what he's talking about here. Already we have perfectly used it, okay, in our previous unit, but now he's explaining that we have this method also. That is the method we have used. Even we have used the TLB. I don't know how many of you remember. If you don't remember, just watch the video here. The transaction look aside buffer. We had internal here, some buffer here. There we used to, so this is some kind of cache. What type of cache? It's a hardware cache we do have. Okay, it's not a software. Hardware cache we are using, and using that we are trying to access the information. And there only we have discussed about something called TLB miss and TLB hit. And based on that only we have discussed about the page replacement algorithm. All we have discussed in that particular concept only. Okay, so this is what he's talking about in this particular scenario. Now, coming to other access methods, well, okay, whatever we are doing, whatever we discussed, that only is explaining here. So here he has given an example of your IBM here, index related to other access methods. This is the way. That is a page table I told you, no? That is what he is representing here diagrammatically, so that you can understand how it is actually working. So if you look at here, this particular, so this is a page table. Now this page table will consist of a name. Okay, there we use the table zeros and ones. Here is using the name to represent understand. From this we will be getting that particular page number, that is frame number, and that frame number will be locating the actual information related to your system. So this is a relative file. This is a relative file we have here, and whereas coming to this we call it as an index file. So every page, whatever we are accessing or every information we try to access, that will be indexed here. And based upon the name, we will be getting a location of it, and that location we will try to access it from the main memory. And that will provide you the information related to it. So this is what it's talking about access method. The next thing what we have here is something called as directory structures. Okay, so now we are going to discuss about directories. What do you mean by directories? Nothing but which actually consists of set of files. What kind of file? Related information file. It will consist of related information. A similar kind. Other words, what we can say is a similar kind of file that we are going to place in one location is what we call it as directory. The best example what I gave you, something like, we created a directory called C program. So it will consist of related kinds. So this is a directory. So it will consist of related kind of files like, add.c, subtract.c, addition.c, so on. Multiple programs. Okay. So that means to say directory structures here. So this is the way how we represent here. So file 1 is present in one directory, file 2 in different directories. Okay, now these will be residing in the disk also. Disk, see there is no much difference between disk and directory and files. Okay, when we have multiple files of similar type, we'll place it in one folder. That folder is what we calling it as a directory. Same way, if we have multiple files of different things, that we are going to call it as different, place it in different directories. Now, if we will talk about a directory structure here, we'll take some time in order to explain this. So what he's doing is exactly our disk, whatever we have. Disk is nothing but your backing store, whatever we are having here. That is what he's saying it as disk. So let us suppose this is your backing store, right? In this we have different blocks like this, where we store our information. Now that is what he's saying. The disk can be this. This is the backing store. Backing store. We also call it as a disk. Now this particular disk dividing into what is we are subdividing into partitions. If you see here, this particular disk we have blocks here. I am dividing that into some portion. Like this is one block. This is another block. Here we have another block. Okay, this way. Okay, I'll show you in this video. Suppose let us suppose this is your disk. Now this disk, what we are going to do, we will subdivide it. Since we know that our files, there are multiple different type of files have been supported by our operating system, right? We can store multiple different type of operating files. Now these particular files, whatever we are storing, that files will have different types, and we cannot store everything. Like we have .exe, .doc file, .txt files, .com files, .lib files, .dll files, right? Now all these files we cannot store it in one particular location. So what it's doing is, whatever the disk we are using here, this particular disk is actually subdividing into different partitions, maybe like quarters. And one quarter will consist of information or the files related to one type. Maybe this particular quarter, this portion I'm using for storing the .exe, .com executable files, I'm storing it. Whereas coming to this particular, I am using this portion of the disk for storing the text file, this hardware. Okay, this is the hardware I'm talking about, where we are storing the information. Whereas coming to this particular portion, I might be using it for source program. Source programs means .c, .obj, that program. And this one I will be using for system related information like library files, like .lib files, .dll files. In this way, we will be dividing our disk into different portions. And all these portions can be combined together. We will call it as a RAID. Okay, RAID is the one which actually provides protections with respect to the failure. All these files will be combined and represented in a format of file. Now, whatever the information we are storing it up, okay, that we call it as mini disk. Like this is one particular mini disk. This portion, whatever I'm seeing here, this is one mini disk, we can call it up. This is another mini disk. This one is another mini disk, and this portion is another mini disk. Now, this one, wherever we are storing this information, this mini disk, we call it as, the technical term given for this is volume. Okay. Now, this is another volume. This is another volume, and this one is another volume. Now, I will give you a practical example now so that it becomes easy for you to understand. Let us suppose you people are having a laptop, right? You people have a lappy? Yes. You people are having laptop. So initially, whenever you install operating system, you divide your disk into C drive, D drive, E drive, F. I think you people remember. In C drive, you people store only the application related. Whatever the applications you're installing, that related only files you have in your C drive, isn't it? When you come to D drive, you may be using it for storing other information like movies, videos, something. E drive you might be using for storing information related to your studies like textbooks, like in a PDF format, your notes and all. Whereas coming to F drive, you might be using it for storing your personal information like photos and all. You have C drive, E, D, E and F. These are what we call it as volume. Means among this diagram, whatever you're seeing here, this particular diagram, this is your C drive, D drive, E drive, and F drive. That is what it's saying. And each one is a volume. Okay. And this volume, so every volume will have a directory. Means every volume, whatever you're representing here, that C drive, D drive, again we have E, F, right? This one will have one particular device called device directory. Every volume will maintain this device directory, and this directory consists of information related to the file present in that particular directory. Okay, or the volume whatever we have. This is what the partition is giving. See, this is your disk. This is your hardware disk. Magnetic disk, you can say. This is a magnetic disk. This magnetic disk now is chopped into two partitions, part A and part B. And part A, initially you will have directory. This will consist of information related to the files present in that. This is something like your C drive, and this is something like your D drive, and this is something like your E drive. So related to all the files present in the E drive, that will have information present in this particular directory. And same way, all the files present in the D drive will be having information stored in this particular directory. So this directory will consist of a table. That table will maintain all the information related to this particular file. This is the way how the partition is exactly done. Okay. So each partition is what we call it as here is volume. So within your system, you have a C drive, that is one volume. You have a D drive, that is another volume. Same way E drive, volume, F drive, volume. Well, some people like to have only two partitions. So they will be having something like C and D drive. So in D, they will store all the information, all files, different type of files. C drive is used for application. That is also partition. So here we have only two partitions. But whereas coming to here C, D, E, F, we have multiple partitions. So that's what he is saying in this particular disk structure. I hope it's very clear. If you might have understood. Now, coming to particular thing like directory we are talking about here, right? So here basically we have different type of other files. We do have other different type of files. These are exclusively okay. These files are exclusively supported by different operating systems. Different types of operating systems generally support. For example, here he has taken an example of a Solaris. This is one type of operating system. So whenever we are using the Solaris operating system, it will actually generate some system related files, and those are what we are seeing here. Okay, let me clear it up. It's yeah. The first one what we have is TMPS. TMP is nothing but temporary file system. TMP is nothing but temporary. FS is nothing but file system. So this is a temporary file system created for what? It is created for the main memory, your RAM. You can see here it is clearly representing volatile main memory. That is nothing but these are the temporary files created for your RAM. Okay, for only for getting the information related to when the system has rebooted, when the system has crashed, that information. So whenever your system is again turned off and on, this particular temporary file will be vanished from the system. Again, a new one will be created. Same way we have something called object file system. Now this is not the object file what is created once your program is getting compiled. This is related to your main memory. So here we call it as a virtual file system. This is related to kernel. This particular file system is actually used by used by this particular kernel. Using this kernel is used, and why he is using it? Whenever we are debugging one particular application, we want to get information related to that, and we know that one particular program may not be using it for longer duration. Once the process is completed, we'll remove that. That's the reason it is a temporary virtual file. Same way we have something called CTFS. It is also a virtual file, and CT is nothing but contract virtual file used for managing information related to system boot up. Whenever your system is booting it up, whenever your system is running, that information will be present in this. And later on we have something called as LOPF loopback. This is actually used for well, these files will be shuffled from one location to another location, right? For example, you might be storing first initial in a D drive, and then you shifted it to something called F drive. So that information will be present in this particular loop back. Okay. So it allows one file system to be accessed in place of another. So that means whatever you want to access one file, you're trying to access another. Means you're just duplicating the files and placing in different locations. Then we have something called as ProFS. This is related to the process file. This is a virtual file system which consists of information related to the process. PROC is nothing but process. That process file information will be present in that. Apart from that, we have general purpose file systems here, UFS and ZFS. Well, we will not be able to look, well, all these files, whatever are generated are with respect to the system. So we may not be able to see these kind of files in our, visually we cannot see it. Internally, these files are actually generated for the operating system. We cannot see them. What the files we can see is with extension like executable files, text files, all those we can see. But these files are system related, so we cannot see it. I hope it's very clear now. Now coming to the operations that we can perform on this. Well, this is related to what are the different operations we can perform onto your directory. These are the file. These are the one what we can perform here. So basically, as I told you that every directory will maintain a symbol table. This symbol table means every directory, like in the previous diagram you have seen, we have a directory here, and here we have files. Now this directory consists of information related to this particular file, right? Now that files, whatever we have, that will be in the directory, will be stored in a format of a table, symbolic table. And this will consist of information related to this particular file. Now, using this particular table, we can perform different operations. What kind of operation we can perform is like inserting some entry into it. We can delete an entry if the file is no longer required. Okay, and same way we can rename that particular files and all that operations we can perform in the directory. Apart from that, these are the standard operations which are provided for all different type of operating systems. So what are those? Searching a file. If you want to search a file within a directory, okay, so within this particular directory, you want to search one particular file. You can easily do it using this. Now you might be asking, sir, we already created a file, something called as, okay, something called as movies, and within that we have multiple folders where we have this table. Well, that table we cannot visualize it, but within your system, you people have search option. Whenever you open a movie folder, you will have a search option onto the top right corner. There you can type the name of the file. Then automatically it will search in this particular files within that particular folder directory. That is what it means to say here, searching a file. Then we can create a new file that where Alt Control N short form, or you can use right click your mouse and then you can create new and then you can create a directory. Same way you can delete a directory when you no longer require it. Apart from that, if you want a list also we can get it. I will show you practically, so it's easy at the end of the class. Then we have renaming a file, so you can rename a file right within the directory. Finally, traverse. Traverse is nothing but you're traversing that entire folder. Like from movie folder, you have multiple, some 100 movies are there of different languages in a different files. So you will simply traverse them one by one. That is what comes under traversing. And mostly how we can traverse, you people might know it when you people have completed data structures. Now, there you might have written programs related to traversing a tree. So same way we can traverse this particular files and directories, whatever we are having. Well, coming to the operations, okay, while operations are completed, we'll see the directory levels here. So basically we have different type of levels, what we already told you. So these are the one what we have. So first one is single level directory. Now in this topic we'll cover first single level and two level, and then we'll complete this session. In the next session we'll discuss about tree structured directory, acyclic and general. So these two are basic, easy. Most easiest one are these two, single level and two level. Let's see what are exactly these are. Single level directory, if we talk about, okay, let me show the diagram. Single level directory, if we talk about here, what it means to say that all files, all different type of files will be stored in a single directory. Means there is no partition, whether it is a .exe file, .dll file, .lib file, .txt file, .doc file, .ppt, .xls, all these files including your programming files, .c, .java, .obj. All these files you people are storing in a single folder, and that is what is calling it a single directory. Okay, so it is the simplest directory to maintain because we have only a single folder. This is single folder we have, and within that folder we can store all these files, right? But there exist some limitations. I think you can understand. What are the limitations we may be coming across in this particular this? Since we are storing, first thing is we are storing particular directory. Well, as the time progresses, initially you may be having some 2 or 3 files, but as the time progresses, let us suppose 4 years within your BTech, you might be creating so many different type of files. Now all these files will be stored here, means you will be having some millions of files in a single directory. Then is it possible for you to remember what are the different names you have given for that particular file? If you want to access, it becomes highly impractical. That is what it's saying. If a multiple files are present on, okay, it becomes very difficult for a system, I mean the user, to remember the names of the particular file. And moreover, since we are storing all the names of the files in a single location, then that they should have unique names. You cannot store the same type of file with the same name, like, then there will be having a problem. Okay, you cannot store that. And moreover, if that same system is been used by multiple users, for example, we have a single system, this is used by two users are using the system. I gave, okay, let us take example of few people only. So roll number 1 and 2 use the same system. I give you people to write a program add.c. Now what this, let us suppose roll number 1 came at one time and she has written a program and stored it as add.c. Okay, so since we have a single level directory, that will be stored in the same directory. Then roll number 2 came, she also wrote the same program. Since I told both of them to give the name of the file as add, she will also be storing it with add.c. Now let us suppose both have been accepted. Both in single level, both the names have been accepted. Now next time whenever they are coming, is it possible to determine which one belongs to which one? Until and unless you are opening that file and seeing if both of them have used the same variables, it's highly impractical to identify which variable, which file belongs to which particular user. That means we are simply violating that particular rule. That is a major drawback of your single level directory. It's very typical, and moreover, it's very difficult to remember the names if multiple. As I told you that if there are multiple millions of files are present in a system, then definitely it's highly impossible to remember each and every file name. Few file names we can remember, not all. Okay, this is the structure represented here. So we have different file structures: cat, bo, a, test, data, mail, content, hex, record. These are the different directories we have, files. And within that, we are storing all these files. These are the different files what we are having here. So this is a single level structure. Well, rather than having benefits, more disadvantages are only more in this particular single level directory. Now to overcome this problem, this unique name problem, whatever we are having here, you can see here we have a unique name problem, right? So this problem we can overcome using your two-level directory. Yes, using two-level directory we can overcome this particular problem. How? So here I'll show you the diagram. You can see here in a two-level directory, what we are going to do exactly here is that we will be maintaining two levels. This is, if you see this particular diagram, initially we don't have this. These are the directories. These are the directories, but we call it as master file directory. Now this directory will not consist of files. I mean, this will consist of files, but here initially it will have only username and password. This master file directory, here in this particular directory, we will be allocating space to individual users. So there are 4 users here. You can see here, user 1. Now user 1 whenever logs in, okay, to this particular master file directory, he can use it, you can do it using username and password. He can log in into that particular username. And when he logs into that particular location, whatever the space is allocated to him, within that space only he can store his own files. You can see cat, bo, a, test. All these files belongs to this particular user. And whenever another user logs in, that user will be given certain space. Let me clear it up. Yeah. So you can see here, user 2 is given this space, and that is using it for storing his own directory. So these are user file directories. We have a master file directory, user. Remember, this master file directory cannot be accessed by user. User cannot access it. Who can access it? This will be allocated by the administrator. Administrator. The system administrator will allocate this space to user. Now user can start creating different folders, directories. So where he can store that? He can store that directories in a user file directory, and that file directory will be having different files. Now, do you think now whatever the files present in user 1, these files cannot be accessed by user 2. Same way, whatever the files are present in user 2, they cannot be accessed by user 1, 3 or 4. Okay, now that violation problem is then removed, right? So here the same two files can have a same name. You can see here A and A. These are same directories, but since these are located in two different locations, they can have a same name. Like, okay, for example, if you can see here, data is it. Is having a directory called data. Same way, user 4 is having a directory called data. But these are located in two different locations, so they can access it. So that violation problem is actually eliminated in this particular scenario. I hope it's very clear. That problem is actually being removed by this particular two-level directory. But even though it is having means overcome the problem that with respect to your single level directory, it still has problems. So means advantages that name collisions have been overcome, but it still have limitation. What is the limitation it is having is it simply isolates user 1 from user 2, and it isolates user 2 from remaining users. Means they are independent. See, if user 1, this is the advantage when one user is independent of another user. It means there is no contact between user 1 and user 2. There is no contact required between these users, then that is an advantage, isolation. But if they are sharing, let us suppose both of them want to share a common file. This is a common file. And this common file need to be shared by user 1 and user 2, then this particular directory structure is having a disadvantage. Why? Because it cannot allow two different users to access the same file. But these two users wanted to share this particular file. Again, so there's a problem here. That is a disadvantage. But if user 1 is independent of user 2, they don't have any information, no relation between them, whatever they are doing it, then this is the advantage. That is the only disadvantage what we have in this particular two-level directory. Now, apart from that, what he's doing is we can overcome that problem. Okay, so we can try to overcome that problem, but how we can do it is only if the operating system gives permission to access files from other users. If the operating system gives permission to access from other users, then we can do it. And here comes the major problem. The problem is related to path. Let me spend some time here. Okay, just 3 minutes. We need to provide a path name. I'll give example. Let us suppose you people, user 1 is this. He want to access one of the file. Okay, one particular A. So does he have to give any path name? He don't have to give any path name. Why? He is already present in his own account. He can simply call A/A and that file will be opened. But if we want to access the file A present in user 2, can he do it if the permission is given? He can't simply call /A. If he is giving this particular path name, then this particular file will open, not this one. But he wants to use this. Then what he's saying is the user has to give the entire path name from that particular user, like something user 2. Now user 1 is giving a path name user 2/A. Then the system will try to access the file that is present in user 2 account, and that will be opened for user 1 for accessing purpose. This is the way we need to be. So whenever we want to access the path name from a different user, then we need to give the entire path name. Entire path name has to be given, like username, then another location, then if there is another location, that one. This you people can say. So that is what we need to show it up in this particular scenario. And whereas coming to within the same file, like user 4 is accessing files within his own account, simply he can give /x/data. He will get the file. But if he's trying to access anything like /a of user 3, then he has to give user 3/a. Okay, then only he can access. Well, some systems doesn't support, they provide different kind of mechanism here. They want to provide the volumes also. Volume also they require. Volume in the sense something like in our system we have volumes like C drive, D drive, E. Suppose you people are located in C drive. You want to access some file in D drive. What we need to do? First we need to give D/enter. Once we enter into that, then you need to give the path. Maybe movies, English movie, and within that English Terminator. Then that put .mp4, and that file will be open for you people for execution purpose. This is the way. So some systems support this kind of start mechanism. Like we need to provide the volumes. After volume, you need to give the path name. So something like volume/path name, and that we have to give, and based on that, it will perform the operation. So this is the way how exactly two-level directory structure works. So this is all about for today's session. In the next session, we will be discussing about the remaining three directory structures what we have. Thank you. Thank you for watching my video.